So hi everyone. Today we'll be discussing about CycleGANs. So in my previous video, I've already discussed about generative modeling basics as well as about basic GANs. So I think if you are not aware of this, so you should go back and see those videos because we might be taking some references from my previous videos. So basically, CycleGAN has been a breakthrough model which has a very fascinating application in the field of image translation. So let's first of all understand what is image translation. So it's basically tweaking an image such that the core content of the image remains the same, but the domain or the styling of the image changes out. For example, like if you have been using PixArt or like some Instagram filter, so you must have seen that there are coming multiple filters coming in, where the core of the image remains the same, but the you some sort of filter comes in on the image. So image translation. So it can be an example of image translation. They might like they is a very popular problem on summer to winter translation. So given the same image in taken in summer, if it can be translated into a winter scenario, if the same picture are taken in winter, so summer to winter translation, or like a painting painted by MF Hussain to be translated to some other famous artist. So image translation basically means like changing the domain and style, but keeping the core content of the image intact. So how can this problem be chased out? So like we have a image from a particular domain X, and we wish to convert that image into to a different domain Y. So an early guess on this can be that we can have such a training pair where we have images for the same object in both the domains, and eventually we train some autoencoder and we can get that image. So for example, if we are trying to train a cycle GAN for summer to winter, winter to summer translation, we can have a summer and winter picture of the same image in the training set, and eventually we can train that. But like if you start thinking on this problem, preparing such a data set is very tough, because you take a picture in summer, then you wait for a whole season to take a other picture in the next season. So eventually it is just not possible. Like in summer to winter translation to even it is possible, like you can wait for 1 year, but like cases like painting translation from MF Hussain to Da Vinci, so in that cases the X and Y samples won't even exist together, like the same painting done by MF Hussain and the same painting done by Da Vinci. So that is just not possible. So having such data set is just not possible, like having like in the training data set we have same image for both the domains. This is just not possible. So how to train a cycle GAN? And this is where GANs come into the picture. So what we will be doing is that we would be taking up images from both the domains. Like for example, I would be talking in terms of summer to winter and winter to summer translation this particular video. So when we're talking about taking images from both the domains, so we would be having a collection of images from summer, and we would be having a collection of images from winter. But these two image datasets are just not related. These are random images that are not related to each other. So in the summer collection, the images are just completely different from that in winter. They have no relevance. Now using this particular two datasets, we would be trying to train a cycle GAN. So, why does it call a cycle GAN? You will come to know this shortly. So, in my previous video, I was discussing about GAN. So, there is a pair of generator and discriminator that exist, where the generator tries to generate fake images, and the discriminator tries to classify the image as real or fake. Now, in case of cycle GANs, we will be having multiple generators and multiple discriminators. It does make sense, right? Because what we're trying to do here is that we're trying to form an image translator that can translate from summer to winter and winter to summer. So for one translation, we have one pair generator discriminator. For summer to winter and winter to summer, we have a different pair. That is why we will be having multiple generators and multiple discriminators. So we'll try to understand how does a cycle GAN works. So assume that we are trying to train a cycle GAN from summer to winter and winter to summer translation. So the first step is to take random samples from a particular domain. Assume that summer is domain A and winter is domain B. So we took some random samples from domain A and fed it to a generator that generates A to B. That means summer to winter images. Now, if you remember in a general GAN, we used to take some random noise and then used to generate images. But in case of cycle GAN, we are taking an image from a particular domain and trying to translate to a other domain. So there are no random images now. Now, whatever image that generator A underscore B has generated for winter, we would be feeding the same image to generator B to A. That means winter to summer. So and converting the image generated by domain by generator A to B into a summer image again. So basically, so if you understand the entire flow, that is image from domain A, it is getting fed to generator A to B. Now it which generates an image B. Makes sense? Now this image B is again fed to a generator B to A, which generates image A again. So summer image, generator summer to winter, generates a winter image, generator winter to summer, and which again generates a summer image. That is your input. So the input and output remains the same. Similarly, we have for the other domain as well, image B, generator B to A, giving out an image A, and which is getting fed to generator A to B, giving out an image B again. So that is why they're called cycle GANs, because you can see couple of generators getting involved. And what we are trying to do is that whatever we are feeding in, we are trying to get the same output in the end. It does make sense, right? Because you are feeding a summer image to a summer to winter translator, which generates a winter image. You fed the winter image again to a winter to summer translator to generate a summer image. As I told you earlier, that the core of the image remains the same, but the just the styling changes. So as we change the style from summer to winter, winter to summer, so eventually in the end we should get the same image that we fed earlier. Now the loss function that we are using here is a bit different as compared to general GAN. So in a general GAN, what we are trying to do is that we are trying to minimize and maximize the classification error between real versus fake. If you remember, the generator was trying to maximize that classification error, while the discriminator was trying to reduce that. But in case of a cycle GAN, we have three parts coming in. Adversarial loss due to misclassification between real and fake, here where the discriminators role come in. If you remember from previous GANs video, the second loss is identity loss. This is something interesting. So assume that we have a generator A to B, that means summer to winter. Now assume that if I feed it a winter image, make sense? What generator A to B is expecting? It is expecting a summer image in input, right? And giving out a winter image. But what if I feed it a winter image? The particular generator should not touch it, right? So identity loss is that if we are feeding it an image from the opposite domain, for which the generator is generating an image, it should not touch it. That is an identity loss. So if the generator makes certain changes, that is counted as an error. And cyclic loss. So loss is very obvious, as you saw in the cycle. What we are inputting is what we are expecting in the output. So any difference between the two is taken as a cycle loss. So so the total loss becomes the summation of the three: adversarial loss, identity loss, and cyclic loss. So out of these three losses, in identity loss and cyclic loss, we don't have any role of discriminators coming in. But in case of adversarial loss, we have a role of discriminator coming in for both the so we'd be having two discriminators, one for the summer domain, another for the winter domain, which would be calculating the adversarial loss for us, as we did in general GANs.